We are doing a hypothesis test for the population mean, and we are using the traditional method. A magazine article stated that the average age of women getting married for the first time is 26 years. A researcher decides to test this claim, and so she selects a random sample of 25 women who were recently married and found the average age to be 25.1 years with a standard deviation of 3 years. We'd like to test the hypothesis at an alpha of 0.02. In this problem, the standard deviation is 3 years, and it appears that this is a sample standard deviation based on these 25 women. And so for that reason, we will be using the t-table. The level of significance is 0.02. And it appears that the claim that they're trying to test is that the average age is 26. So when we go to write our hypotheses, the null always has the equal sign in it. So the is 26 looks like it's the claim, so we'll attach the claim to that. And the alternative would be it's not 26, so we'll use a not equal to sign. The critical values are going to be found on the t-table, and again, that's because this standard deviation appears to be a sample standard deviation rather than a population one. If it was population, we'd use the z-table, but we're going to use the t-table. Let me bring up the t-table. On the t-table, the degrees of freedom that are down the left-hand side are one less than your sample size. So we would go to 24 because our sample size is 25. So we're looking on line 24. This is a two-tailed test because of the equal, not equal to, and we would go across on the two-tailed line until we find the 0.02, which was the alpha, or the level of significance. We come down. I see a 2.492. This is a two-tailed test, so the critical values are actually plus or minus 2.492. There's two critical values. One's over here on the right, one's on the left. There'll be two critical regions. Each tail will be a critical region. So again, we got those from the t-table. You're going to calculate your test value. It is a t, and it's calculated using this formula. The sample mean that was obtained was 25. The hypothesized mean was 26. The sample standard deviation was 3, and the sample size was 25. So your denominator is 3 divided by the square root of 25. When you put this in your calculator, you're going to get negative 1.50. So that's your test value. Then to complete the next step, you look where this test value is on this picture. It's right up here. It's in a non-critical region. These tails are the critical regions. It's in a non-critical region. It's in the center part. And so you do not reject. So we do not reject the null hypothesis because the test value was not in either critical region. It wasn't in either of the tail regions, so you do not reject the null hypothesis. Then let's look back up at our hypotheses. We are not able to reject the null. We cannot reject this, so we cannot reject this claim. That creates a little muddy water because it doesn't really mean the claim is true. You just can't reject it. So in the last step, your sentence is a little murky, but you just say something like, there is not enough evidence to reject the claim that the average age is 26. But don't write that you've proved that the average age is 26. You haven't really done that. You've just shown that there's not enough evidence to say it's not 26.